next test is we want to find out how our patients are converting their nutrients into energy. There's 500 different types of diets being recommended out there on the internet, and only one of them is going to be right for your patient. Not everyone can handle a lot of carbs or do well on a Mediterranean diet. Not everyone can handle or do well on a paleo type diet because it's too much protein for them. And not everyone is going to do well on a keto type diet for the same reason. If they can't break the nutrient down into the proper cofactors and working parts, we're not going to be able to extract any energy from it. So we're going to look at carbohydrates first. These dietary carbohydrates are converted into pyruvate by a process called glycolysis. It's a multi-step process, but it has a repeating set of cofactors that are required. And if the patient's missing any of these, their blood sugar is going to go up and they're not going to turn their glucose into pyruvate. Now, glucose can also be synthesized in the body through a process called gluconeogenesis. That's B6 dependent, so we're seeing different cofactors for this. And this requires really good protein digestion and absorption because the glucose is synthesized off of amino acids. Now, glucose from gluconeogenesis is also converted into pyruvate, but through a slightly different process and pathway. So again, we need to know exactly what cofactors we need to worry about. And if this process is inhibited, we're going to limit the flow of pyruvate into the mitochondria, into that citric acid cycle where the beginnings of ATP generation happen. So if we get results back and we see a huge mismatch like this, this is a B3 problem. And that is a cofactor that we need on both of the pathways that convert glucose into pyruvate. And if we see a big drop off like this, that's a whole different can of worms. That is a limit right here at pyruvate dehydrogenase, and that we would want to do something about because we need that citrate. Now, pyruvate can be broken down through 4 different pathways. So primary purpose here is to decrease the amount of pyruvate. We want it to go somewhere and do something, not just sit there and pile up. Ideally, some of it drops down to citrate, but there's other ways to deal with that. So we just want to see that pyruvate broken down, and that is a variety of minerals, B vitamins, and other cofactors to promote that process. Proteins are a different animal entirely. We look at 4 different markers for amino acid breakdown. They're all branched chain amino acids. When we start to see values here go high, we have a problem on our hands. Now, in a perfect world, we break down and absorb and degrade our dietary proteins into different amino acids, including these branched chain amino acids. But our inheritance actually determines our tolerable protein load. There are people out there who have trouble processing ammonia, or who will have excess oxidative stress if they get too much protein in play and can't process it properly. And we don't want this to happen. Problems in protein breakdown are fairly common in inherited mutational disorders, which are usually diagnosed in childhood. They're also fairly common in urea cycle disorders, which can escape detection sometimes if they're actually low activity instead of loss of function mutations. And the problem here is that if we're not breaking these amino acids down properly, then the alpha keto acids that we measure here are actually toxic metabolites, and they can shut down other processes like the one that converts glucose into pyruvate and other primary biochemical functions. So if we see high values on our protein breakdown pathway, we want to do something about it. We want to apply the necessary nutrients to support that breakdown. The step that we measure here is very early in the process. So there are a variety of nutrients that we can put into play to help our patients process their proteins more efficiently. And in addition, we would want to decrease that protein intake a little bit so they can handle the load. Now, fatty acid oxidation, again, a whole different animal. Ideally, fatty acid oxidation takes place in our liver mitochondria, and it happens through a process called beta oxidation. Now, in a perfect world, beta oxidation takes medium chain and other fats and turns them into something we need. It turns them into citrate. This is a really good idea. So if we have a block in our pyruvate dehydrogenase, if we can't get pyruvate to turn into citrate, These are people who might actually do better on a higher fat diet because then they can turn their fatty acids into citrate instead. Now, we will see beta oxidation increase if we're fasting, if we're on a high fat diet or a keto type diet. But even at that, we really shouldn't ever see a lot of excess down here. And there's a reason for that. We'll get into that in a moment. The important thing to remember is beta oxidation can be compromised by lifestyle. If we have a fatty liver, if we've developed type 2 diabetes, if we have an L-carnitine deficiency, not everyone can synthesize carnitine well. It's a methylation dependent process. And if we're vegetarian or vegan, we may not get enough carnitine through our diet to meet our needs. There are inherited low activity enzyme variants throughout the beta oxidation pathway, as well as in carnitine synthesis, so this can happen. And the moral to the story is if we're seeing high levels on our results, we're actually seeing an overload of a secondary pathway, a backup system called omega oxidation that's meant to be a very minor path for those medium chain and other fatty acids in the liver and the kidney. If it's asked to do too much, if there's too much fat for the beta oxidation pathway to handle, that's when we see adipate and suberate go up. We can see beta hydroxybutyrate go up, and that's not a good idea because this system is being overloaded and it can't handle the load for long. Now, the good thing about beta oxidation is if we've got fairly normal levels of adipate and suberate, we may see it turning into succinate, and that's another really good idea for some people who don't drop alpha ketoglutarate down into succinate terribly well. We need to keep this wheel spinning. Citric acid cycle is just that. It's supposed to go in a circle. So we need to make sure we can feed in nutrients at specific points around the circle to keep them moving. So looking at these three different aspects, carbohydrates, proteins, and fat breakdown, we can see that we might need different diets for different types of problems. If we have someone who shows up with a fatty acid oxidation defect, we want to avoid prolonged fasting. Overnight's okay, but not longer. We want to avoid alcohol. It's going to further inhibit the pathway. We want to avoid excess protein. They're going to get overloaded. We also want to provide the cofactors to break those fatty acids down. Now, a couple that weren't on the chart or don't get talked about much, B5 is a big one. Molybdenum sometimes comes into play here, and these might be patients who are having trouble with sulfites as well. Sulforaphane is a broccoli extract that has been shown to upregulate beta oxidation. So it's something we might consider if we're seeing evidence of an omega pathway overload, that higher adipate and suberate. We always want to give some omega-3 fatty acids to support mitochondrial membranes. And these patients may do better grazing because they can't handle a big fat load or a big protein load all at once. They may do better with smaller meals chunked out during the day. And as far as fat intake goes, some of them are going to do really well with medium chain triglycerides and not do well with longer chain fatty acids. And they'll show up with certain symptoms. You'll be able to recognize them. And then there are other people who are going to do really well on a high fat diet as long as it doesn't involve medium chain triglycerides, and they're going to show up with other signs and symptoms. So all this enzyme activity helps us decide the macronutrient ratios that we want to recommend for an individual patient. There are going to be people out there who can't handle a lot of fat and who can't handle a ton of protein, but who are going to do really well on that pyruvate to citrate pathway. And those are people who are going to do better on a complex carbohydrate Mediterranean type diet. For those people, we want to limit protein. We don't want to go too low, but we want to limit it. We don't want to have them eating, 2 hamburgers per meal, every meal of every day. They may do better with extra glycine and extra carnitine to help move what protein they do get around better. And then we want to support the breakdown pathway with those nutrients that we know are specific to these amino acid products.